You've made your own functions. You've learned how to declare a value for type. Now we'll tie both of those together and make your own types, which as you'll see is at the heart of Swift programming. A general rule about types is they are capitalized words in code. So let's go over here to our code, and I'm going to get rid of the preview so we can have a little more space here. And you can start to see a few things. Look at this code, and you'll see a lot of things that are capitalized. Content view, view, double, string, and text are all types, sometimes referred to as objects. And notice again content view, where we define a content view object. There's three things you should note about an object. First, an object is a group of values called properties that define that object. Banner image, color, and title are examples in the content view object. You'll also find a group of functions called methods that work on those properties or on other methods. Pizza size and pizza order text are examples in content view. Finally, types might adopt features of another type to make a new variation of the original type. Content view, for example, adopts methods and properties from the view type. View is a special type called a protocol. Protocols are types that are incomplete, requiring you to add specific methods and properties to the object for the object to work. For example, view requires the variable body. Content view has the word struct in front of it. There are two kinds of objects, known as value and reference types. Close the app, and we're going to make a new playground by hitting the rectangle, and open it up. Structs like content view and simple types like string and int are value types. They take one value for every instance no matter what. So let's make a struct to explore this. I'm going to make a struct called struct A. Okay? And you start to make a struct by just typing the word struct. And you can see there it is right in our autocomplete. So I'm going to go ahead and click on that. I'm going to call it struct A. And then you would put a code block. And that's the basic structure of a struct. Now you're going to put inside of here some values. So let's put in one value to make our struct. We're going to be very simple. So I'm going to put a var. I'm going to call this item. And I'm going to make it double. So I declare a variable just like I always would. Now underneath that, we're going to put something special. Now objects need an initialized state. Up to now, we've been relying on a quirk of struct that it doesn't need a special method to initialize properties like item. We either assign a value directly or the struct forces us to add values. Behind the curtain, struct uses a special method required for all objects called init. And so I'm going to type in init here. And you can see it comes right up into the autocomplete as the first one. So I'll go ahead and press that little return button here. And it just needs parameters. Notice it doesn't say func init, it just says init. You just need the init for this particular function, even though it is actually a function. And then you'll put in parentheses item, and you'll match your type to double. And then you put a code block. And what you're going to do in that code block is assign the item that is in the parameter to the item that's in the struct, which is a variable. Now, you could just sort of think you might want to do this, item equals item, and you'll get an error. And there's the error. Okay, so I'm going to hit return here. And let's go look at that error. And it says item is a let constant. So what's going on here? Let's go ahead and close that error up so we can read this a little easier. And look at this code. Item inside of init, because it is a function, has a scope only inside the function. So the item we're talking about in here is the item that is in the parameter. So that parameter one, first of all, is a constant, which is true of all parameters. And so that has a problem that you can't assign anything to it. But we're also having this idea that I'm trying to assign something inside of itself, and that doesn't seem to make any sense. Instead, we want to assign item to the item that's up here, this one right here, okay? So how do we get there? Well, there's a special word for this, and that says, I'm going to talk about the stuff that's in struct. I'm going to talk about stuff that's inside myself, and that is the word self. And if you put self in front of it, you notice our error disappears. So self.item is referring to item. Now, I don't use self all the time. You could. Anytime you're talking about the struct A item, you could talk about self. I tend to use it only when there is an ambiguity, like in this case, where I can't tell one from the other. I'm going to use this variable with self in order to get the explicit idea across of what we're doing. So that's our first struct, and I can start using it. So let's, for example, just make a variable, and I'm going to call it A, and I'll assign it to struct. So var A equals struct A, and I can look at the parameter list here and notice it's all in autocomplete as soon as you define all this. And then it says item is double, and I'm just going to make it 5. Next step I'm going to do is I'm going to take A and make another variable. I'm going to call that one A1. And I'm going to assign it to A. And then once I assign it to A, I can now take A1 and change its value. So how do I change a value? Well, A1 is an object. If you put a dot after the name of an object, it will list its properties and methods in the autocomplete. And the dot simply says, this is something that's inside of that particular struct, or what we'll see later is a class, or any kind of object. You've seen that up top with self has a dot after it, and it's the same thing. And you can see on our list that we only really have item and self here, and I'm going to use item, so I'll just hit return. And I'll change that to 21. Now, let's just see what the values that we have are. So I'm going to hit print here, and I'm going to do a dot item. So I see what the value of item is. A1 dot item. And let's put in here struct. And now I can go ahead and run that code. And let's go ahead and take a look at the code here, and you can see here that we get values that we expected. So A is equal to 5.0, A1 is equal to 21.0, and we've just mentioned that it's a struct. Now I'm going to do something here. I'm going to take this code, and let's copy it and paste it underneath. Because there's another way of doing this, okay? And you can see it's already giving me errors here because I've duplicated everything. But now I'm going to change this code around a little bit, okay? So let's start up top here, and I'm going to change the word struct here to the word class. Now, class does something different than struct. It works the same way that we need the variable and the init inside, but I'm going to call this class B. And its guts are going to be the same in our case. It can be anything you want, but we're just going to use the exact case so we can see what happens differently with classes than with structs. And then underneath this, let's just make sure everything becomes class B. Okay, and that's going to be class B. This is going to be B1 equals B instead of A1 equals A. And then we'll do this one as B1 item equals 21. And then we'll change all this up too. So now we've got our class. And here, by the way, init is mandatory. Okay, for classes, unlike struct, init is mandatory. And there's a reason for that I'll get to in a little bit. Just so you know, that's the reason I did this, is so that I can copy it, because usually you don't even need that init in a struct. And most people will leave it out. Okay, so we've got the class B. Let's go ahead and run this, and you get something entirely different. So in this case, both B and B1 have been assigned to 21. So what happened? Okay, so let's go through this code here. Variable A struct A does pretty much the same thing as variable B class B. We create an object. But when we get to A1 equals A and B1 equals B, that's where the magic happens. In A1 equals A, again, what we're doing is we're creating a new value. And so it's got its own space in memory, and it's completely independent. So when we changed item for A1, it only changed in A1. In B1, what I'm doing is I'm saying where B is. So var B1 equals B really means B1 is going to have a new name for the location of B. It points to the same object. So when I change b1.item, I'm changing the same object. And so I get the same value for both B and B1. This is what's known as a reference type. And reference types are one set of types that you'll find in Swift and in many programming languages. And on the other side, you'll have value types like structs and basic values such as string and int. And there are differences, and you use these two in very different ways. We'll get into why you use one over the other very shortly. But for now, you know you'll use class to make objects of reference types and structs to make objects of value types.